Hi everybody. In this video we are going to figure out this equation over here, which tells us how to find the area A of a circle. So over here we have a circle, and let's pretend this circle is like a pizza pie. We are going to take that pizza pie and we're going to slice it up into 4 pieces. So we have 4 slices over here. And then we're going to do something which maybe your parents or grandparents told you never to do. We're going to play with our food. So we're going to take these 4 slices and we're going to rearrange them so that they look like this. We're just going to put them next to each other like this. Now, an important thing to keep in mind over here is that the area, meaning the amount of space inside of this circle, the original pizza pie before we started slicing it up and playing with it, is exactly the same as the amount of space inside these 4 slices. Okay, hopefully you agree that if we just cut something up and rearrange it, we're not actually changing the amount of space that's inside of that thing. Or in other words, if I were to eat this entire pizza pie, or if I were to eat these 4 slices over here, I would be eating the exact same amount of pizza, whether I ate it when it was in circle form like this, or after rearranging the slices like that. If I eat this, it's exactly the same as me eating this, right? So the area of this is the same as the area in here, okay? Now, what is the length from here to here? What is the length from here to here, okay? What is that? Well, if you think about it, this pizza slice, let's say that this slice came from over here. This part of it over here originally came from this line over here. And what is that line? That is the radius of this circle, right? So the length of this side over here, let's call that R, R being the length of the radius of this circle. All right. Now, something else which we'll ask is, what is the length from here to here? Well, where did this part come from? This is like the crust, right, of that pizza. Where did this part come from? Well, this part came from the crust of the pizza, but not the whole thing all the way around, because we have these 2 other slices up here. So this is just the crust of 2 of the slices, right? So maybe from here to here. And what is that? Well, the entire thing, the entire crust is like the circumference of the circle, right? So the entire crust of the pizza would be C. Oh, C is a good letter because C is the first letter of crust, just like it's the first letter of circumference. So the entire crust of the pizza would be the circumference of the circle. And we know that the circumference of a circle is equal to 2 pi r. That's one of the equations that we derived in the last video. But this over here is not the entire circumference of the circle. It's only half of it. So if we take the circumference and divide it by 2, what would we get? We would also have to divide this side by 2. So these 2's over here would cancel. So we would get C over 2 is equal to pi r. So this is telling us that if the full circumference is equal to 2 pi r, then half of the circumference is equal to just pi r. So this part over here would just be pi r, pi times r. Okay? All right. So we still don't know the area of the circle yet, but we're making progress. All right. And by the way, what shape is this? Is this any shape which you recognize? No, it isn't. But you're going to see that as we slice this up more, it's going to start looking more and more like a shape that you are familiar with. So let's do just that. I'm going to scroll down here a little bit. So now we have the same pizza pie that we had before, but instead of slicing it up into 4 pieces, we're going to slice it up into 8 pieces, just like at a normal pizza parlor. They usually slice it up into 8 slices there. Okay, and again, we're going to play with our food, and we're going to rearrange those slices like this, because I guess we're not feeling very hungry, so we just want to play with it and put all the pieces together. Now, again, it's important to realize that the area of this circle, I didn't do very well there. Pretend that I did that better. The area of this circle is exactly the same as the area inside of all of this here, because when we sliced that pizza up and we played with our food, we're not changing the amount of space that's inside of there, right? We're just rearranging it. Okay, again, like I said before, if we were to eat this pizza just like it is over here, and if somebody else was to eat these slices over here, then really we ate the same exact amount of pizza. It doesn't matter how they're arranged. Okay, so the area of this is the same as the area of this. Now, what else do we know? We know that, well, how long is it from here to here? Again, this is just one of the slices of pizza. Maybe it's this slice of pizza over here, and this part came from over here. So again, I'm just making that a little bit thicker so you can see it. Again, this is just the radius of this circle. So if the radius of the circle is r, then the length of this is just r. It's the radius of that circle. And what about the length from here to here? That's 4 crusts, right? So let's look at 4 crusts from this one. 1, 2, 3, 4. So once again, the length from here to here is just half of the full circumference of that circle. And just like we said before, we figured out that half of a circumference is equal to pi r. So this part over here, the length of it is equal to pi r, just like it was before. Okay, so really we got the same answers over here that we got the last time. So what was the point of doing this if we got the same answers? Well, hopefully you realize that when we sliced this pizza up a little bit more so that these slices got thinner than they used to be, the shape started looking a little bit more. What shape is this starting to look a little bit more like? It's starting to look a little bit more like a rectangle. All right, hopefully you see that. It's still not exactly a rectangle, but the thinner these slices become, the closer it gets to an actual rectangle. Okay, now imagine then that we took that pizza and we really started playing with it a lot, and we sliced it. We just kept slicing and 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 slicing, and we just kept slicing and slicing and slicing and slicing till we got those slices really, really, really thin. And then imagine putting all those super thin slices of pizza right next to each other. Well, the more we slice and the thinner we make those slices, the more this would start looking like an actual rectangle, right? And we can get this as close to a rectangle as we want just by slicing more and more and more. Excuse me. All right, but this part over here would still be equal to the length of the radius of the circle, and this part over here would still be the length of half of the circumference of the circle, which is pi times r. But since this is a rectangle now, or as close to a rectangle as we like, and we know how to find the area of a rectangle, then we'll be able to find the area of the circle, because remember, the area of this circle is exactly the same as the area of all those slices put together. So the area of this circle is exactly the same as the area of a rectangle. Now we know how to find the area of a rectangle. It's just, hopefully you have learned that to find the area of a rectangle, you just do the length times the width, right? So the area of this rectangle A is equal to the length, which is pi r, times the width, which is r. And here we have r times r. Another way of writing that is r to the second power, or r squared. So the area of this rectangle is equal to pi r squared. But wait a minute, like I said earlier in the video, when we took those slices and just rearranged them, we didn't change the amount of space that was in there. So the area of this rectangle is actually the exact same as the area of this circle. So we've actually found the area of the circle, which is what we wanted to get all along. So that is the derivation for the formula for the area of a circle. So if we know what the radius of the circle is, then we can just take the radius and square it, meaning multiply it with itself, and then multiply the result by pi, and that would tell us how much space is inside the circle, how many square units are inside the circle. And the last thing that I'm going to say, you might remember from a previous video that area is two-dimensional, right? Radius is one-dimensional, diameter is one-dimensional, circumference is one-dimensional, but area is two-dimensional. And notice that r raised to the second power over here is consistent with area being two-dimensional, because the radius itself is one-dimensional. So let's say that we're measuring the radius in inches. Then when we do the radius times the radius, and we do some unit analysis there, we look at the units, we would be doing inches times inches, which is square inches. Or if we were measuring the radius in centimeters, then when we go to multiply the radius with itself, we do the radius squared, we would be doing centimeters times centimeters. That gives us square centimeters. So the fact that the radius here is raised to the power of 2 in this formula, that is consistent with what we learned earlier about the area being two-dimensional. Okay, so I'm going to end the video there, and have a great day.